Welcome back, folks. In this video, we will look at document similarity with doc2vec. And the objective is that students will perform document similarity analysis using a pre-made tutorial offered by Jensen. So let's start with talking about what word embeddings are. Word embeddings are a way to place words within a multi-dimensional space. Now, what does that mean, multi-dimensional space? Let's start with the three dimensions that we as humans know about. We know about up, down, left, right, and in, out, right? We live in a three-dimensional world, and we humans are really good at that. But computers can think in terms of many more dimensions, 400 or 300, or many more, millions. And for us humans to say, wait, what's a fourth dimension? What is that? Yeah, it's really hard for us to understand what's going on there. But computers can do that. And so we can have a computer take all the words of a document and put them in some multi-dimensional space, like a 300-dimensional space, and all the words that are similar to each other are near each other in that space, and the words that are different from those other words are farther away. And it's gradient. It's not binary. It's gradient. And so we can measure just how far they are away from each other or close to each other in this multi-dimensional space. So to give you an example, I'll give you an example with Fast Text, which is software that was open sourced by Facebook a little bit ago, a couple years ago or more. It is open source, free, lightweight library that allows users to learn text representations and text classifiers. It works on standard generic hardware. Cool. Here's a little video, a 1-minute video if you'd like to look at that. So let me just give you a demo of what this is. So what I have here is, I'm using a terminal here, and I'm in a directory on my hard drive that has, I've already created a model here, but let me just show you real quick. If I look at Book of Mormon tokenized, I have the Book of Mormon here. Let me zoom in so you can see this a little better. I have each sentence in the Book of Mormon as one paragraph or one paragraph, one hard return, right? And I've already prepared it. Well, this is actually from Dr. Lonsdale, Daryl Lonsdale. I prepared it. He's prepared it, really. He's lowercase everything, and we don't have any punctuation either. That's what you need to do in order to create the model. And what I can do is say, hey, Fast Text, let's get the nearest neighbors of the Book of Mormon model that has been binarized. And let's say I want to look at faith. What are the nearest neighbors of faith in the Book of Mormon in this 300-dimensional, I'm not sure the number of dimensions, I'm not sure, but this multi-dimensional space? Grace, remission, repentance, Christ, miracles, etc. And these numbers right here represent just how close grace is to faith and remission is to faith, etc. We can just try, I don't know, what should we try here? How about wicked? What do we get with wicked? We get remain, become, becoming, proud, victory, seen, probation, etc. Okay, so you get the idea. I also created a model with the Bible. So here's the Bible. Let's look at faith in the Bible. Patience, Christ, promise, hope, gospel, obedience, godliness, suffering, circumcision, repentance. How about wicked in the Bible? Oh, that's interesting. Froward, righteous, mischief, workers, walketh, transgressors, etc. So the point I'm trying to get across here is that I took some text, the Book of Mormon, and I created a multi-dimensional space so I could look at how close certain words are, the nearest neighbors of those words. And then I did a different multi-dimensional space for the Bible. And the reason I point this out is because we can actually do that with documents, like full-on documents, not just words. We can take documents and put them into a multi-dimensional space. And again, documents that are more similar to each other are closer to each other in this multi-dimensional space, while dissimilar documents are farther from each other. So let's say we have a 300-dimensional space, which we humans can't really understand. And it figures out where to place document 1. And then some other document that's close to it, like the words within it are near, or like the other words in the first document, will be placed somewhere close to that first document in this 300-dimensional space. That's the idea behind word embeddings and document embeddings and character embeddings and byte pair embeddings and paragraph embeddings. This idea that you create this multidimensional space with the machine learning algorithm, and then you can say which words or which documents or which paragraphs or which sentences. You can do sent2vec. Sent2vec is another algorithm. Which of these human generated words or characters or sentences or paragraphs or documents are like other words around it. Okay, so that's a lot of hand waving. I was doing all sorts of hand waving. I talk with my hands a lot. Let me give you a demo. Let's just work through a tutorial that is available on the GenSim webpage. They have a Google Colab notebook of this algorithm doc2vec. So let's just go to this webpage. Here it is, doc2vec. And they have a nice tutorial, you work through this tutorial. You can see how they do it. The idea of vectors, how do you turn human language into vectors? Like that is numbers that the computer can deal with. They talk about that there, bag of words, turning each of these words in these word types, that is unique words, into a number or count of how many words there are in each of these sentences. I'll let you read through this on your own. There's a review of Word2vec. I just kind of did a quick demo of a word embedding like Word2vec with fast text from Facebook, paragraph vectors. Anyway, at the very bottom of this webpage, I want to get down to the very bottom. I'll let you read as you like. There is a very bottom. Come on, here we go. At the very bottom, there are two links here. One is to a PY file and one is to an IPYNB. That is an IPython notebook. It's a Google notebook or notebook file. It's not only Google, but if I download this thing, which I've already done, and I'll do it again just for the fun of it, just to start afresh. Save it on top of the previous thing. And so here it downloads, it went to my hard drive. And if I go to my Google Drive, if I log into Google and go to my Google Drive, top right of my screen, I'm circling the Google Drive icon, right? And then I do new, top left, let me zoom in a bit here. Top left, it says new, and I do file upload, the second option, file upload right there. And then I look for that file I just downloaded, which is right there, run doc2vec li.y, or excuse me, IPYNB. I upload that. Upload complete, bottom right of my screen says upload complete. Awesome. Let me remove myself so you can see that right there. I click on that link to open it up. And here it is. Again, they have the whole tutorial right here. I'll let you read through it if you like, as you like. What I have a couple videos on how to work with Google Colab notebooks, but you click on this play button to play a file, or excuse me, to play a cell of code. And so anyway, you should work through this, skim through what they're saying here. This is basically just a copy of the website, but then now it's in a Google Colab notebook format. Let me just run all of it at once. If I run every last cell, it'll take a couple seconds here, maybe tens of seconds here to work through what it needs to do. I can see that it's executing down here. It says executing 8 seconds. Good. Let's see, what is it doing now? It's still executing. Awesome. I'll let you read through what they're using here to test this idea of seeing what documents are similar to other documents. Is a corpus called the LING corpus. Maybe I should stop. Let's stop there and take a look at that LING corpus real quick. LING background corpus. Here's their training set. That's the actual paper. Let me just take a look at, I think they have a web page. No, they don't have a web page. Well, let's just read what they say. For this tutorial, we'll be training our model using the LING background corpus listed in included in GenSim. GenSim is a Python module. This corpus contains 314 documents selected from the Australian Broadcasting Corporation's News Mail service, which provides text emails of headline stories and covers a number of broad topics. Awesome. And we'll test our model by eye using a much shorter LING corpus, which contains 50 documents. So that is what they're using. So let's just kind of jump to the final result way down here, down at the very bottom. So here, let's take a look at this document. So document 299 says Australia will take on France in the doubles rubber of the Davis Cup tennis final today, with the tie leveled at Wayne, Arthurs, and these other people are scheduled to lead Australia in the doubles, okay, against these other people. Okay, so that's a document that they're saying, hey, here's a document. Now I want to see what is the second most, like what's the most similar document to it? And it chooses itself. Good, that's understandable. That document 299 was chosen as the most similar document to document 299. That's good. It's the exact same document. But the second most similar document is this one right here, which says Australian cricket captain Steve Waugh, I'm not sure how to pronounce that, has supported fast bowler Brett Lee after criticism of his intimidatory bowling in the South African tailwinders. Anyway, so it's talking about cricket. So it feels that document is the second most similar document. The least similar document is down here, 216, with this score. And it says, senior Taliban official confirmed the Islamic militia would begin handing over its last bastion of Kandahar to Pashtun tribal leaders, etc. Has nothing to do with sports, so it felt like that document was the least similar to the document about Australian tennis there. So yeah, that's just a quick demo of how document similarity works with this GenSim doc2vec model. Okay, so there you have it. That is a quick way to get similarity, to like gauge, actually quantify the similarity of documents with a score. Like this number right there, these numbers quantify how close a certain document is to another document within this multidimensional space. So it's another way of analyzing the similarity of human language. Okay, so that really brings us to a quick conclusion of this video. We just simply relied on this tutorial that is available at the GenSim website. Let me just zip to the top of this page real quick. At the GenSim website here, where they have this tutorial about their doc2vec model. And again, I zipped to the bottom of this screen and I just downloaded this IPYNB file and uploaded it to my Google Colab area. So, okay. As always, I'm super happy to help. If you get stuck trying to do what I just did, let me know. I'll help you out. See ya.